Today we are going to talk about symmetry and the different types of symmetry that an object can have. Each one of these pictures has some sort of symmetry to it. So as we go through the different types of symmetry, each one of these will have some sort of symmetry to it. The first type of symmetry we're going to talk about is a reflectional symmetry. And how that works is it is symmetry across a line. Just as when we did a reflection, we used a line to go across for our reflection. So what we need for that is a line. We're specifically going to work just with horizontal and vertical lines when we talk about symmetry across a line or reflectional symmetry. The easiest way to imagine it is if you would fold your paper on that line, would what's on one side of the fold exactly match up with what's on the other side of the fold? So for horizontal symmetry, we would be drawing a horizontal line across our figure, and what's on the top would exactly match what's on the bottom. So which one or ones of the four pictures have horizontal reflectional symmetry? The CBS symbol. So if I draw a horizontal line across the CBS symbol, the top half would fold perfectly onto the bottom half. Any others? Bottom right corner. So if I draw a horizontal line across that word, is the top half exactly going to land on the bottom half if I fold it up? Not quite. So it does look like there's something going on there, I mean, with the little curly cues coming up and stuff. But folding isn't going to do it, not folding horizontally anyway. The word mirror. So if I draw a horizontal line there, does the top land on the bottom? Okay, so not on that one. What about, just to end out the problem, I guess, we'll look at the other one. Folding work there? No. Okay. So it looks like just the CBS symbol has the horizontal. Vertical would be folding over a vertical line. So which one or ones of the four pictures have vertical? Mirror does. So if I fold right down the middle of that, they used a fancy font so that the ROR exactly matches the M. The CBS symbol could be folded right down the middle vertically as well and have the two halves match. What about the other two? The recycle symbol is tempting for people because we think a triangle. Triangles in general, that could work, but because of the arrows, it's not going to quite work here. There's a little bit too much detail in that picture for that to work out perfectly. And the symmetry one also does not work. So for vertical, we have the CBS and we have the mirror. So then both would mean that it has both types of those, and we can see from the lines that we drew in that that's going to be the CBS symbol only. It has both types. So reflectional symmetry is across a line, a horizontal fold or a vertical fold that would allow the two halves to match exactly. Questions on reflectional symmetry? For rotational symmetry, how it works, what was our other word for rotation? A turn. So how it works is it's a turn. If we turn the object in some way, it should exactly match what it used to be. What did we need to be able to do a rotation? A point that we're going to rotate around and an angle, so we know how far we're turning that object. So we do need the object as well, but the two specific things for rotationals, we need a point that we're going to turn around, and we need the angle that tells us how many degrees we're going to make that turn. We are always going to use for our point the very center of the object. So when we talk about a rotational symmetry, we're going to talk about using the very center of the object as being our point. So in the 4 pictures above, if we put a point right exactly in the center, that would be the point that we would be wanting to rotate around. General rotational symmetry could be any angle. I'm going to specify that I do not want to include 180 or 360 degrees, but any other angle. Technically, those would be general as well, but we're going to give those a different name. So when we say general, we're turning by some angle. It could be any angle, but I'm going to exclude the 180 and the 360 from these examples. So in those 4 pictures, which one or ones of them could I turn and have it land right where it was, matching exactly the original, but not by 180 or 360? The recycle symbol. How many degrees would I turn the recycle symbol to have it line up back where it is? How can we figure it out? I'm getting lots of different answers. I've heard the right answer, but I've also heard a lot of wrong answers. So how can we figure out how many degrees I need to turn it so that it's going to land right back where it started? Its base is an equilateral triangle. So the angles themselves would be 60, but will turning at 60 make it match? How many points on it match the same? 3, right? There's kind of the 3 different parts. If I turned it all the way around 360, it would definitely be back to where it was. But if it has 3 matching points, how far could I turn it so that a new point is going to be where the old point was? 120. The 360 divided up to the 3 matching pieces. So that one has 120 degree rotational symmetry. 360 would make the full circle, and if I turn it 1/3 of that circle, then the next arrow would be filling the previous arrow spot. Okay. Questions on that? Any other ones have an angle of rotation different than 180 or 360? Okay, yep, that is the only one. So then we'll talk about point symmetry. Point symmetry is specifically 180 degrees. So if we say that a figure has point symmetry, we don't have to say what the angle is. Saying point symmetry means that it has 180 degree rotational symmetry. So which one or ones could I turn around 180 degrees and have it line back up with where it started? The CBS symbol. Any more? The word symmetry. So again, they use kind of a fancy font on that symmetry so that one of the Y's will match the T when it turns around, and the other Y kind of looks like an S upside down. So turning that around its center, it would land right back where it is. Also the CBS symbol. The CBS symbol is actually a really special thing there because it has so many types of symmetry. It is a theorem for us that if a figure has both reflectional symmetries, then it has point rotational. So CBS had both of the reflectionals. It was horizontal reflectional and vertical reflectional. That means it has to also have point rotational. But it does not work the other way. Just because it has point rotational, it will not necessarily have the reflectionals. And we can see that in the word symmetry. That symmetry has the rotational, but not the reflectionals. But if you can find something that has both reflectionals, it also must have that rotational as well. Okay? The last one is 360. What can you tell me about 360 rotational? It's going to turn out to be the same exact thing. So what has 360 rotational? Everything. All of those pictures, but anything in general would have 360 rotational because that's just turning it right back to where it started. So when we, in our homework, are talking about rotational symmetries, do not include 360 because 360 just isn't special. Everything has it. So it's not special to talk about 360. So in your homework, when you talk about rotational symmetries, either talk about general as being some angle or point as being specifically 180. Questions on rotational? Okay, for your homework then, you're going to be looking at the Lesson 4 homework page, which should now be the back page of your packet. The first question says, give 3 different letters, one with each different kind of reflectional. So we're not talking about rotational in number 1, just reflectional. So the 3 different kinds would be horizontal, vertical, and both. Use only capital letters. Okay, so just using the capital alphabet. Give me 3 letters, one that has vertical, one that has horizontal, one that has both, and tell me what you think they are. So say this one's the vertical, this one's the horizontal, this one's both. You can do that just by drawing in the lines. That's fine. Or you can write the words there. Pay attention to what the questions ask in terms of what kinds of symmetry. So number 2 is still just talking about reflectional. Okay, number 3 now it starts talking about rotational. So pay attention to what kind. Again, with rotational, you could do the general, any angle, or you could do point being 180, but don't do 360 because that's just not special. Yeah. Okay?